So let's get started talking about AI use cases for video. And the way that I've broken this down is I'm breaking it down into three main categories. A little bit, I want to talk about an introduction to machine learning. And I know we have kind of an understanding of machine learning. I just kind of want to walk through a few things on a super high level. And mainly, I want to make sure that as we start to talk about things like video as a use case, that we're focusing on the aspects of machine learning that are applicable, and we're ignoring the parts that are not applicable. The second thing I want to talk about is just a couple of generic AI use cases. And the reason I want to talk about these two specific AI use cases is I want to talk about how they're used with respect to kind of supporting video itself. And then lastly, I want to spend a little bit of time talking about video as a use case. So we'll get started with kind of an introduction to machine learning. Now, just as a way of background, I want to at least spend a second and talk a little bit about artificial general intelligence in comparison to narrow AI. I love science fiction. I love reading classic science fiction, and one of the grandfathers of science fiction is Isaac Asimov. He wrote in the 40s and 50s up until the 80s when he passed away. And in the 40s, he came up with really this concept of artificial intelligence. He coined the term, and it was a robot who had been had constructed a brain that allowed it to think like a human being. It had feelings. It could intuit things. As a matter of fact, and I didn't know this until much later, if you're a fan of Star Trek, specifically Star Trek The Next Generation with Data, and Data had a positronic brain. Well, that positronic brain, that term, the positronic brain, is an Isaac Asimov creation. So it was a throwback really to Isaac Asimov. We're not going to talk about this. It is an interesting subject, and it is important to kind of know AI's history, but unfortunately what happens today is us focusing on kind of the brain aspect of it. It kind of hurts our understanding of what we're actually trying to do. It'd be kind of like if I'm trying to go and get a degree as an aviation engineer. I want to go and build airplanes. And so what I do is I focus all my energy as a bird watcher, because birds fly and I want to be able to build things that fly. So therefore I'm going to go and watch birds. That's not really the right direction. That's not really the way that we should approach this. And wanting to build AI and focusing on the brain would be a similar mistake. So we're not going to do that. What we're going to focus on is narrow AI. Now with narrow AI, we're trying to solve a single problem. And when we start to look at a use case like video, we're actually going to be stringing a number of these problems together. So some examples would be things like face recognition or face identification. And we've talked about one of my favorite use cases, at least as an example of artificial intelligence, is locating faces in a frame and then taking some action based off of those. Something like speech to text is another good example. Or natural language processing, where we're not trying to understand the text, we're trying to understand the meaning behind the text. And then playing games. As we've discussed many times, there's really two basic fields of artificial intelligence: a rules-based and machine learning. Now, rules-based is older. It's really what we've been focusing on since the 50s. And from the 1950s up until the early 2000s, everything was rules-based. And this is where we were doing if-then statements. Imagine just hundreds or thousands or millions of if-then statements. And I always love the example of IBM's Big Blue. Big Blue in the late 1990s beat Gary Kasparov 2 games out of 3. And Garry Kasparov at the time was the best chess player in the world. And so a computer beating the world's best chess player is a huge accomplishment. It was rules-based. Now, one of the problems with rules-based is it needs to have an exhaustive understanding of the domain set. You can't have anything left that we don't have an if-then statement for. And for a game like chess, though there are a lot of different permutations, combinations of chess pieces on the board, but for a game like chess, it's at least tangible, right? There are a finite, though large, a finite number of different states the board can be in. And once the board state is understood, the optimal next move can be chosen. We don't do this much anymore today. And the reason that we don't do this much today is because it's so unbelievably complex. And you have to have this exhaustive understanding of every possible condition. Imagine if you're trying to manage a telecom network. Can you really know the state of all, if you look at like the large operators around the world, right? They have 100, 200, 300, 400 million users. I need to have something that has an exact understanding of every one of those users and every one of the cell sites and every piece of backhaul equipment. It's impossible. So in around the 2010 time frame, plus or minus, we started to see more and more use of this term machine learning. And really the value of this, the reason that machine learning became important was because of processing power development. The concepts, the math behind machine learning aren't new. I mean, they've been around since the 80s. But really the problem was to solve some of these problems we wanted to solve, we didn't have the computational power to do it. And so machine learning is really the result of that. A subcomponent of machine learning is called deep learning. And all that is more complicated machine learning. 99.999% of the time, when we use the term AI, we really mean machine learning. We don't, it's very rare that we mean this rules-based. And it's also very, very rare that we mean that artificial general intelligence. Now, really in practice, machine learning is solving very simple problems. So if you're trying to build your own machine learning algorithm to do something, you could use machine learning for that, but it's typically fairly simplistic in comparison to deep learning. So most problems are really deep learning problems, anything of any real value. So again, most of the time we just use the term machine learning, but in reality, it is really deep learning. And I'll talk about what that means in a second. There's a distinction in that. So the more complicated the problem, the more complex the model needs to be. And that's a good thing for us to think about between machine learning and deep learning. And here's my favorite example. It's not a perfect example, but it's a decent example, just so you can kind of have an idea. Let's say I wanted to build a model that could tell the difference between a cat and a dog. Okay, cool. And that's going to have some level of complexity, whatever that is. And this is a little bit more of a subjective analogy. Cats versus dogs. If I wanted to build a model that didn't tell me the difference between a cat and a dog, it told me the difference between the different breeds of dogs. Okay, that's a lot more complicated. To tell the difference between the different breeds means that you'll have to have analyzed it more. And I know I'm kind of keep this in a little bit of a subjective manner, but that's okay. I think you understand kind of what I'm getting at. I mean, it's the same thing as a human being. I'm not a dog person, nor am I a cat person. My wife has a cat right now. And my wife had dogs for a number of years. And notice the phraseology. My wife did, not me. And she could tell you the difference. She could tell you it's part this and part that, and this is a trait of that dog and all that. I got nothing on that. It doesn't mean anything to me. But I do know there are these different breeds, and I know that learning that is not easy, right? I can make a similar analogy with birds. My sister-in-law is a bird watcher, and so she could name all of these different birds. We go a little bit deeper into this analogy, and we could say, I want to identify my dog, a specific dog. Now, for let's just say the use case is I want to create an algorithm that I connect up to traffic cameras. And I want to be able to identify a dog that's lost. So I have a picture of the dog, and now I'm able to find not a dog of the same breed, but that particular dog. And you can see that would be a lot more complicated. And so that's kind of the mentality I wanted us to think about as we're going through this. The more complex the problem that we're trying to solve, the more complex the learning model. And this is really the key thing in my mind. It all boils down to what's the problem you're trying to solve. If you don't have that, you don't have anything. So, and I've used I've told this story before. Some of my colleagues, when we first started getting into AI, they'd come up to me and say, I want to build an AI model. I'll say, great, what do you want it to do? AI. It's like, okay, well what do you want it to solve, right? Because depending on what you're trying to do, the model will change significantly, as well as the data that you need will change significantly. And I've presented this one many times. I love this slide. This is my favorite slide. And so I need to gather data, and that data needs to be representative of what it is I'm trying to do, the problem I'm trying to solve. If I'm trying to solve something that's in the natural language processing arena, I need something that has a lot of words. I'm going to take books off of Gutenberg.org. If I'm going to try to do things that's more of an image recognition thing, I need things that are representative pictures. If I'm trying to do something that is based off of identifying when a piece of network equipment fails, I need the data that's going, the logs and the counters of that piece of equipment, and I need a flag that says we had a failure or not. I need data that represents the problem I'm trying to solve. And getting this data is very, very difficult. And that's really one of the big challenges. And that's the reason that there's so much stuff happening with respect to data. Data is really the gold. Why do you think in Europe they created this GDPR? It wasn't about really the fact that privacy was important. It was about privacy being important, but it was the fact that people were using this data for ways that were not intended. Why do you think there was this big uproar in 2017 after Cambridge Analytica had illegally gotten data from Facebook? And so Facebook allowed it to happen. Facebook didn't prevent it from happening. And they claimed to influence the United States election. Now, whether they did or not, I don't know. And I'm not really trying to get into that type of a discussion. But my point is they're making that claim. And given the fact that they had access to 50 million people's data, it's not a rational claim. And they got that data using uncool methods. So data is important. If we're trying to deal with video, then it's going to be video footage. And then we have to decide, what do we want to do with that video footage? The second thing we have is we need to create our model to solve a problem. And this is where the training is coming in. This is where I'm taking this data and I'm learning how to do a prediction based off of that data. And I think this is critical. This is where the data science comes in. So this is where we're actually solving that problem that we talked about a few minutes ago. And so if I don't have good representative data, then my solution is probably not going to be very good or very accurate or very applicable. And always the example I like to use. And I had the opportunity to do a couple of webinars last week for a client, and there were a number of people, 100 people or so on one of the webinars. And I asked the question, I said, hey, if I were to take and collect data, do a survey of all of us that are on this call, and get your input on whatever the fact is a marketing type survey, an opinion poll, whatever it is, it doesn't really matter. Is that going to be good data for me to create a general model that was applicable for people across the entire United States? And my argument is no, because all of the data is from one group of people that have a similar background. We're all in the high-tech industry. And so therefore, if what you're trying to do is take a survey that 100 of us who are in the telecom industry fill out and make and apply that data to the travel industry, it's probably not going to give you very good results. You're trying to apply it to the medical industry, probably not going to give you very good results. Okay, so it has to be representative. Now, once we've trained the model, once we've been able to take this data and learn how to make that prediction, we've taken 5,000 cat video or cat pictures and 5,000 dog pictures, and we can tell the difference between a cat and a dog. I was doing some prep for a webinar next week, and actually somebody else had put together a presentation, and they were saying they took pictures of burritos and tacos, and they were trying to teach an AI algorithm, burrito versus taco, which I think is a much better AI algorithm than cat versus dog personally. But that's just, because I like burritos and I like tacos. Once I've learned how to tell the difference between a cat and a dog, I then can deploy my model. And this is where we're really going to use the model for something new. We have new data. We do a prediction. Now, this is really the important part, in my opinion. I'm not saying that building the AI algorithm isn't important, and I'm not saying gathering the data isn't important. But really the thing that I think is most important for us is this last part, which is the action that we need to take. What is the action that needs to be taken here? My favorite example is the camera app on our smartphone. So if I were to pull out my smartphone and open my camera app and point it at myself, a box would form around my face. And so that is doing a form of AI that's doing face location. It's locating the face in the frame. Now, what happened is Samsung or Apple or Google or whoever is created your smartphone app had a whole bunch of pictures, and it trained a model based off of those pictures of how to identify faces. It taught it what to look for. And then we deployed it in our smartphone. And now we're using it. What's the action that this results in? Well, in the case of the smartphone app, that action is an autofocus. And that's how it autofocuses on my face. We can look at many, many other examples, but that's really that beginning to end process I want us to see. How do I approach getting the data? How do I approach training the model? Both of those things are going to be completely dependent on what's really the action I want to be able to take. What's the problem I want to be able to solve? Let me pause for a second. Questions, comments, at any point you can throw questions into the chat if you would like. All right, excellent.
I like the burrito versus taco example because you can eat all the evidence.
Exactly. I love the burrito versus taco. One of the other ones is I heard somebody else present this, and he would say, what I'm trying to determine, is it a hot dog or not a hot dog? right? So that's what he would say during his whole presentation. Hot dog, not hot dog. I still like taco burrito better. Okay. Once we've trained this model, we're going to deploy it someplace. I could deploy it within the cloud and then use an API call to get to it. And if you've ever done any of the Google API or Google AI, they have a trained model and you can use their trained model. They charge you for it, but you're using an API call. So if I'm trying to do natural language processing, it would record my speech, send the recording up to a cloud, it would process it and give me a response back. We see this in things like Alexa. If I were to go and say, hey, Alexa, what's the weather in Chicago? Well, what Alexa's doing is recording that. She's looking for that trigger phrase of, hey, Alexa. It records everything that's after the hey, Alexa, and then it sends that to a server, processes it, and sends the results back. And we'll get into that a little bit more in a second with respect to natural language processing. To deploy something locally is where I'm building the algorithm into the device itself. My smartphone app is a good example. Another example I really like is I was talking to someone at Mobile World Congress a couple of years ago. And what they were doing is they were trying to build an algorithm that they built into a chip that they put into a security camera. And that security camera was actually in apartments of people that are in retirement homes. And what they did is they said, well, what we're going to use an infrared camera. And the reason they wanted an infrared camera is so that they could maintain the people who were living there's privacy versus a regular camera. And they could train that to identify things like someone has fallen or someone seems to be injured in some way. And they wanted that in the camera, and so the camera could then alert if there was a problem. Lots of different ways we could do it. In reality, what we've been talking about is something called supervised learning. And that's where I have data, and I also have an associated tag. Unsupervised learning is also an option. We've actually had meetups where we talked about anomaly detection. Which is a good example of unsupervised learning. And we've talked a bit about reinforcement learning and robotics. Playing games, especially video games, are a good example of where you use reinforcement learning. And I've had an opportunity to talk to a lot of people in the industry over the last few years. And what I'm hearing pretty consistently is 95+% of the time is something like supervised learning. And because it's very difficult to do something with data if you don't have kind of the data set and then the expected thing, right? So if I had a whole bunch of pictures of cats and dogs, but I didn't label them cats and dogs, the best you could do is maybe group them. But you couldn't actually, the algorithm couldn't actually say cat versus dog because we've never taught it cat versus dog. I mean, it's just like in that sense, a child. If a child has never been taught what a cat is or a dog, and it sees something it's never seen before, it's going to maybe guess, but it's not going to guess right because it doesn't know what it is. Or if you've taught a child only the difference between cats versus dogs, and all of a sudden it sees a giraffe. Well, what it may do is it may say, hey, I've never seen that before. What is that? Or it may say, wow, that's a really weird looking dog. Because it doesn't know better. You need to have that context. You need to have the data and you need to have the tag. So most of the time it's going to be supervised learning unless you've got a very narrow niche. If what you're building is drones, if you're building robotics, if you're doing gameplay, it's all reinforcement learning. Okay, so we get a little bit of background. I've got two quick use cases I want to go through, and I'm going to kind of walk through them kind of quickly because I want to get to the video use case. And the first use case is natural language processing. And as we've talked about it, what natural language processing is it's taking human speech, it's taking text and converting it into intent. And that's actually a really hard thing to do. It's not translating each of the individual words. It is looking at the intent of the words in context of the sentence. And there's a lot of things that are associated with that. My simple example I gave a second ago of Alexa, hey Alexa, what's the weather in Chicago? What Alexa is doing, or what the algorithm is doing, is it's one, looking at each of the words, but two, it's going a step deeper, and it's doing something called named entity recognition. What? Okay, that's asking a question. What's information? Weather. Okay, so I say weather. What do I really mean if I say I want the weather? I want to know the temperature and what's the chance of rain. Really, do I really care about what most of the time, the barometric pressure? Do I really care about dew point? Do I really care about wind speed? Do I really care about any of these things? Really what I care about 99.9999% of the time is temperature, what's the chance of rain? Chicago. Well, Chicago is another named entity. And so Chicago points to a geographical location. As a matter of fact, when I say, what's the weather in Chicago, really what the algorithm is doing is it's translating that word Chicago. First, it's saying, it's making a determination which Chicago, probably the most famous Chicago, Chicago, Illinois, not Chicago, Texas, if there is one. And two, it's mapping that to a specific geographical location, probably O'Hare Airport, maybe Midway Airport, the other major airport that's in Chicago. And so when I say, what's the weather in Chicago, it's providing me the temperature and the percentage chance of rain at O'Hare Airport. So you see how it's kind of having to go and look at the intent and convert it in, or look at the words, find the intent and convert it into an action. Everything boils back to that action. Image recognition is another one. Now, really what we're looking at with respect to trying to use AI in video is trying to do a higher amount of image recognition. And image recognition uses a specific kind of type of model called a convolutional neural network, or a CNN. Now, what a convolutional neural network is trying to do, just on a super high level, is if you imagine the video that I'm sending, and so behind me, you see that there's kind of a green screen that's partially hidden by a tapestry of a forest. And so you can see my head and you can see the forest kind of behind me. What convolutional neural networks are doing is it's trying to do some math so we can kind of start to identify things that are in the frame, because the computer doesn't see like you and me. You can look at this and you can say, okay, this is Chris's head and this is the forest out here. What the computer sees is just pixels. It sees numbers. So what it's doing is it's doing math. And what that math is doing is it's trying to take these pixels, apply some math to it to find where are the edges. And so it would see kind of an edge of my face, for example, and it'd see my nose and see the outline of my beard. And then it would take it a step further and then learn how to take that edge and identify that as one, either a face, if we go back to our simple smartphone app example, or me particular, okay? So that's really what convolutional neural network is all about. And so any of these other models that you see, so there's some that will go, you look at like Google, if you send your pictures up to Google, and Apple Photos does something similar as well. It's using AI, and what it's looking for is it's looking for things in the background so it can tell you what the setting was. So it's trying to identify faces based off of other faces that you've identified, and it's trying to identify location. So if I were to go into, be it Google Photos, Apple Photos, or any of these other photo storage apps, and I would say, I want to find all those pictures of my mom on the beach. What it would do is it would search through all of the pictures, finding things that were identified as beach, which may or may not be 100% correct. Maybe they're at a desert and it thinks it's a beach. And it has pictures of my mom in it. So that's what image recognition is all about, is it's trying to process the pixels and then learn how to find something. Some good examples are if I have a picture and I want to blur the faces. So what I may do is I may have one algorithm that locates all of the faces in the picture, and then another procedure that applies a blurring mask to all of those. So with that, I want to go in the last few minutes that we have left, I want to talk about really video. So if I go back to my starting point, my AI and automation lifecycle, the first thing I need to do is I need to have video. I need to get video. Now that's probably not the hardest thing to get these days. If you go to YouTube, you can get thousands and thousands and millions of hours of content. But you need to learn to train it to do something. What is it that you're trying to learn? And that's where it gets very difficult. We need to find something that we want this algorithm to do. Now, maybe it's identify something, maybe it's locate something, maybe it's remove something. If we go back to a discussion that we had a number of months ago, and we talk about deep fakes. Deep fake is an example of what we're trying to do here. What a deep fake is doing is it's taking the video, say the video stream that I'm sending you, and it's locating all the places, or it's finding my face, and it's identifying, okay, I'm turned to the left, I'm turned to the right. And then it's trying to superimpose somebody else's face on my face. And not just superimpose it in the sense of a copy paste, but map it on in such a way so that it shows that that person, makes it look like that person is talking and giving this presentation instead of me. So deepfake is an example of what we're trying to talk about here. So right now we're doing the learning. This is that training. I may be training to find faces. I may be training to do that mapping. And if you've ever, this is actually really cool. If you go, there's a video I saw where someone took the Mona Lisa and mapped the Mona Lisa's face onto actresses' faces and showed them kind of presenting. And it was really fascinating. It looked like the Mona Lisa having a conversation with somebody. That's the problem we're trying to solve, right? So you can kind of see there's multiple components to it. The deploying of the model would be to do that thing. So for example, if I wanted to take the deepfake analogy a little bit further, I could download an algorithm that somebody else has trained, somebody else has developed. And what I could do is I could give it kind of, I'll call it the raw film, and I'll give it, I'll say the new face, and then it will superimpose the new face onto that image, onto that film. And so the output would be that superimposed thing. What is the action that we want to take? Okay. Now I'm going to look at some other examples that aren't deep fakes, but this is kind of that process. And really, why? Why do we care about this? Video traffic is growing. I mean, we have so much content that's coming in, so much user-generated content. If all of our content was coming from a major studio, I wouldn't need AI as much, because if you're watching Stranger Things and I want to put some type of an ad insert, I know what Stranger Things is about. I know what Friends is about. I know what Batman is about. I know what all these shows are about. I, as a human being, could insert an ad very easily. But if I'm dealing with user-generated content and there's millions and millions and millions and trillions of hours of content, I can't possibly have human beings analyze all of it. So how do I do something with that content if I don't have something like AI? So this is a basic workflow for video. And I want to walk through this just briefly so that we can then see in the next slide how we would insert AI into the mix. So typically, if you talk to anybody that's in the content distribution space, what they're going to say is there's 3 phases of content distribution. There's the acquisition phase, which is actually acquiring the content. And that may come from a major studio, or it may be something uploaded to a Vimeo, a YouTube, a Twitch, whatever the appropriate platform is. We then need to prepare the data in such a way so that it can be distributed to different types of devices. And if you ever look at something like YouTube, YouTube actually stores the content in multiple formats. One so that it can be sent to a phone, another so it can be sent to a big screen TV. So we'll store that, we'll prepare it and store it in some type of a content distribution network. And then when a device wants to go and access that content distribution network, it'll have the video streamed to them using the appropriate format. Now, the different types of formats are starting to shrink. There are fewer and fewer over time as smartphones are capable of handling higher and higher things. A lot of it has to do more with bit rate. What is the bit rate that the connection can support? But if I'm watching something on my iPhone versus watching something on my iPad versus watching something on a 4K TV, you can see that the content, the bit rate, the number of bits should change. So let's take that preparation phase for a second, because that preparation phase is really a good opportunity to insert AI. And we can look at that preparation phase as taking whatever my user-generated or my content, be it user-generated or not, decoding that content, encoding it into supported formats, and then saving those into a content delivery network. So really the thing, in my opinion, that's most interesting is right here. Is there something that we can do to insert something here so that we have more knowledge about what's going on with respect to this particular video? Now, maybe it's something that we're trying to determine, is this something we want to make available to people? Is it something that we need to put a parental control over? Is it something that we just need to put a mature content label on? Is it something that we need to blur, or we need to kind of mask out? My wife watches a lot of videos on YouTube, and one of the things that YouTube has done a very good job of is if music is playing that is copyrighted, one of the things it will do is it will just blank out the audio. So it doesn't clip the video. It doesn't say that that video is not allowed. But what it does do is it just kind of blanks out the audio for that period of time. And so we were watching a video one night on YouTube, and just the audio stopped. And then 2 minutes later, it started back up again. And I looked over at my wife and said, that's probably what's happening, is it's probably just blanking that out. Okay, so with this basic workflow, how do we actually do something with this? And so I'm going to look at 2 or 3 examples. And the first example is I want to look at where I'm doing some type of user-generated content, and it's of a very high bandwidth. Now, probably the best example of something like this would be things like maybe security cameras. So I'm going to send all that footage up. Now let's think about this. Do you really need to keep all of security camera footage? Really? Well, no. I mean, if you've got a security camera that's pointed to, out your front door, do you need to keep, hundreds of hours of nothing happening in your front yard? No, you don't need to keep any of that. What do you need to keep? You need to keep all of the content where something happens. And that's going to be the same if it's a security camera you mount at your house, or it's a security camera that you mount in an office suite. So we have security cameras in our office suite, not that I've been to my office in many weeks, and it's storing everything for a period of time. And if we need to look something up, we go and we look it up. What would be really nice if we had a way of analyzing that footage and only keeping the things that were valuable? And again, I'm making a presumption there. What does valuable mean? In this case, it's an event. So I may keep an event, and I may keep the clip associated with the event, and then I may have some other metadata that says the other 8 hours and 59 minutes were deleted because of this 9-hour period of time. This 1 minute was the only thing that was interesting. Now, the other thing that this leads us to, well, one, you can kind of see the value of AI. It's finding whatever these events are, right? Am I able to look at security camera footage and find when there's a problem? Am I able to look at user-generated content and see something, whatever that is? And that's really where that video analytics concept comes in, where we're looking at it to make some type of a determination. Now, one of the locations that people look at for this is in a multi-axis edge computing network. It's something that we see a lot of telecom operators deploying. And so if I put this fairly close to my cell sites, then it's able to do all kinds of great things for me. Another good example that I want to mention is within the area of ad insertion. So what ad insertion is really all about, as the name implies, is it's trying to insert ads. And so if you're watching YouTube and you see an ad, you kind of want that ad to be relevant to you. And so one of the things that people are looking at, Lawrence just put in the chat kind of an example of a meetup that's coming up. Excellent, thank you. But a good example of ad insert is look at like what you see like in YouTube today. Is that ad relevant to you? Now, what does relevant to you means? In my opinion, there's two things. One, it knows who I am and is pushing something to me specifically. Two, it understands what's in the video and it's pushing me an ad that's relevant in the video. Let me give you kind of my favorite example. I'm a big fan of a YouTube channel called Combi Life, and it's this couple who are driving in a classic VW bus around the world. And they started in Chile and they drove up to Alaska, and then they've gotten a new bus and they're starting in the UK and they're trying to drive all the way to Alaska, or all the way to, I'm sorry, to Australia. And so I watch this when I can. And when ads come in, what would be a relevant ad based off of the contents of the video? Well, maybe it's something related to cars, or something related to travel, or something related to the country that they're in. They were just in Portugal, the last video that I watched. And so that's what I'm kind of getting at, is if you're watching something on quilting, having an ad related to craft making. If you're watching an ad that is sports clips, maybe it is going to insert ads on working out or this new NBA All Access plan that they have, or whatever the appropriate thing is. But this is where I see a lot of people trying to push the AI in video, is in this ad insertion space. There are some people who are also trying to do this to have more intelligent video compression. And this is a huge area in the area of virtual reality. So if you think about it, wherever your eye is pointed, I mean, just look at the screen right now. Wherever your eye is pointed, that needs to be absolutely in focus. But as you start to move towards the periphery, right? So I have two screens that are in front of me. I can see the edge of both of those screens, but I can't see what's really on those screens. So therefore, those being out of focus, it doesn't matter because they're already out of focus because of the nature of the way my eyes are designed. And so if we can have more of an intelligence related to where we're expecting the user to be looking, we can send a lot less data on the periphery where it's already blurred anyway. We're not blurring it more. And so that's where people are trying to use artificial intelligence and maybe some eye tracking concepts to try to minimize something. And again, virtual reality is the area that I see, right? Because virtual reality, depending on how it's set up, there's a lot of information that you could send to the headset that the person isn't looking at, so it doesn't really do them any good. So for example, if I've got a headset and I'm doing 360-degree virtual reality, there's something behind me. I can't see it, so why are you sending information to the headset? Whereas if I turn my head, I could see it, and at that point, it should become visible. Now, all of that kind of comes together when we start thinking about the service that we're trying to design. We think about that service, we need to go through kind of the building of the service, and the building is really where we do that training. And so I've built whatever the application is. And now I'm going to deploy that application potentially into something like a multi-access edge computing node. And that is going to allow us to use that application. But what I want you to walk through, I want to walk through this just a little bit. I really like this chart for this reason, because how much AI is there in any application? Well, I've got to have my user input. Okay, so in this case, I'm sending it video footage, frames. I may have to clean it. So for video, what that means is if you typically have full frames and kind of some compressed frames. So how do I get everything to be a full image? I have my program logic, which may pull from an AI algorithm, and then I have my output. So you can see really the only thing that we have that's AI is right here. Now it's quite important, but that's really the only thing that we have within this whole process. Okay, sorry, I kind of got a little fast there at the end, but questions, comments, thoughts before we wrap up for today, because I know a lot of people need to get back to work. Hey guys, I want to thank you so much for hanging out with me here today. The next meetup, I'll be posting some information about it soon.
Well, thanks, Chris. Appreciate all your presentation.
Thank you. Thank you. And Lawrence, feel free to post that that link in the meetup as well.
I did.
Okay, excellent.
Oh, no, I didn't do the meetup. I just did it here. Okay.
Yeah, feel free to.
All right.
All right, guys. Thank you so much.
Thanks.
Have a great week.
All right. Bye.
Thanks, Chris.
Thank you.